Hi all, this is the badging video for the Oxy Acetylene rig at MakeHaven, which is behind the curtain. So we're just going to go over some of the basics and then we will get into using it. So oxyacetylene is oxygen and acetylene mixed together and combusted on fire, and it makes an incredibly hot flame, about 6,300 degrees Fahrenheit at the hottest. So that's super duper hot, and you can use that for a lot of different things. You can weld with it, so that's melting two pieces of metal until they fuse together. You can braze, which is kind of like soldering, except higher temperature. So brazing, you could use like these brass rods and use that as a filler metal. So let's say we had these two hands, which are pieces of metal, and you want to put them together, then we could use that as the filler metal in between these two parent metals to join them together. So that's called brazing. When you're using a softer or lower melting point metal to connect another two pieces of metal. You can use it for cutting. So oxyacetylene is often used for cutting. If you want to cut out shapes and for some reason it doesn't fit on the water jet, or you want it to be a more organic shape versus like the really perfect lines that the water jet makes. So those are all things you can do with it. With the oxyacetylene. You can also just use it for heating. If you just want a big flame just to heat something up, then you can use it for that purpose. So we're going to open up, this is a fire shield, so let's say someone's welding over here and sparks are flying. We really don't want the sparks to hit the explosive gases, so that's why this blanket is around it. So we'll open it up, and these are the accessories that go with the oxyacetylene welding rig. Here is green. The green is oxygen, and when you see red or this tank, that's the acetylene. The acetylene is actually dissolved in acetone. That's how it stays stable. If you were to just compress acetylene to a high pressure, and this is important for later, it would explode on its own. So it's important that it does not get to a very high temperature, and we'll touch on that later. So, and in terms of the hoses match. So red is fuel, in this case acetylene, and green is oxygen. So there are two gauges on these valves on each tank. So the one to the right that's closer to the tank is the pressure of the gas inside of the tank. So right now this valve is closed, so it reads 0, but we're going to open it slowly. Oop. And it sounds like this is open, so we're going to close that. Make sure both of them are closed. And all right, we're going to open this up slowly. All right, so this is sitting somewhere between 12 and 16,000 psi. So that is an enormous amount of pressure. And then this is how much pressure is actually being allowed to go out. So this is called a regulator because it regulates the pressure from the tank down to a lower pressure that we want here. And same with the acetylene. Now, with oxygen, there's a chance that when we leave this valve somewhere in the middle, a little leaks out. So we're just going to open this up all the way until it's snug on the top. The same goes with the acetylene in that it's possible a little leaks out if it's a little bit open, but what's more important is actually that if there's a problem, we want to be able to close it really quickly. So with the acetylene tank, we're just going to open it about half a turn, maybe 1 turn maximum. Just nice and easy. And that's about enough. And just to reiterate, the reason is if there was a problem, we want to be able to run over here and just crank it closed, not be cranking, freaking out. So that's why we do that. We want to take a look at the hoses, make sure we don't hear any leaking sounds. We have soapy water over by the fire extinguisher on the wall. And so if you did think you hear a leak, you can, or if you were to change fittings, it's always a good idea to take the soapy water and spritz it on the hoses and look for any bubbles. If you see any bubbles, that indicates a leak, which should be addressed. And you should mention on Slack and mention to a facilitator that you found a leak, because that would be not good. Another thing to note regarding the fittings is the way, these regulators are different based on the gases going through them, and the way that you make sure they don't get mixed up is that the acetylene ones are counter-threaded. So that means that to tighten it, you turn it to the left. which is the opposite of the normal righty-tighty. So these are normal, and the way you can tell is that you can see these little grooves in all the fittings on the acetylene side, and that indicates that it's a left-handed thread. So you tighten by turning it to the left. Also, these are brass fittings, and that means brass is pretty soft, so when you're tightening it, you just need to get it snug. So you tighten it with your hands first, and then use a wrench and just nice and snug. These aren't like steel fittings that you can crank on. Just nice and snug, and it'll get a good fit. And you never use Teflon tape on these. Teflon is a petroleum product that could combust in a high oxygen environment, so you just snug it up, just brass on brass. So we mentioned that, I believe we mentioned the acetylene should never exceed 15 psi. So in this case, the red on the inside is the psi, and right now we're at 5. So that's below 15, and you can see this is all red, because it's telling you you never want to be there. If you're there, you crank this off very quickly and release that pressure. The way you'd release it is by going up to the nozzle end and opening this so that some gas could come out, like that. So another thing is that the tanks always need to be secured. So let's say you're helping someone put these tanks back. You can't just leave a tank hanging around. The reason being is that if a tank falls over, this has, 15,000 psi. If it were to fall over and this valve gets knocked, that becomes a missile really quickly. So really important that these stay firmly attached to the wall so they cannot fall over. We're gonna cover the safety concerns for Oxy Acetylene. So first of all, it's pretty bright. It's not as bright as other kinds of welding. So when we put on the shield, we'll set the shade level a little bit lower than we would for like stick welding or MIG or something like that. They do make brazing goggles that are specific for the purpose of brazing and maybe even welding with the Oxy Acetylene, so that you don't need to have a whole face shield on, because there isn't a ton of splatter when you're brazing, so you don't need necessarily to protect yourself from the really intense UV and IR to your whole body. You just need to protect your eyes, because that's really a sensitive part there. You do need to have put on a welding jacket. In this case, you may notice I'm wearing shorts, so I'll be putting on longer clothing to protect my legs. We have them here at MakeHaven. And you don't want to be wearing anything synthetic. So if you're wearing anything like even this is synthetic, or jeans that have like stretchy stuff in it, that's all made out of plastic. And any like splattering metal that hits that is just going to melt to your skin, which is super not fun, obviously. So if you're wearing anything synthetic, just make sure to put on the leather apron to protect yourself. Closed-toed shoes, you really don't want splatter getting on your feet, and you really want to make sure that your shoes are laced up nicely so they aren't getting in there. If you're cutting with Oxy Acetylene, then there's a chance that the piece you cut off is a heavy piece of metal that's falling, in which case you want to be very conscious about how and where that's falling, and maybe making sure you're wearing steel toes or putting the steel booties on your feet to make sure your toes are protected. Obviously, there's a lot of heat involved, so you need to be very mindful that it's going to stay hot after you're done, so you need to make sure to use gloves, maybe leave a note on it so no one walking by thinks it's cold when in fact it's hot. And another is fumes are going to be produced, so you want to make sure to use the fume extractor. So that'll make sure that it cleans the air and you're not breathing it in and other people aren't, and it's not getting soot all over the place. So you don't want to be ever welding on a closed vessel. So let's say you have a tank and you think it'd be cool to do something with it. You don't want to be blowing a flame into there unless it's brand new. But if there's any chance that there used to be some liquid in there that was flammable, then it's a bomb, and you're just putting fire right into that bomb. So you need to be really cognizant about that, maybe cutting it in some other way that doesn't involve shooting a flame right into the tank. Also, things like grease and oils and whatnot on your material could light fire, so you need to make sure to clean the material quite well. These tanks can't produce all of the air that you might want, or all the gas that you might want. So you need to bear that in mind, that in this tank, the maximum withdrawal rate is 10 cubic feet per minute. That's defined by 10% of the volume of the tank, so per hour. So if you were to exceed that for the acetylene, what would happen is the acetylene would pull up the acetone that is in there, and so you'd be burning acetone, and the flame would actually turn purple. So that would definitely be an indication that you're blowing way too much gas out and you need to lower your withdrawal rates. There are charts up on the wall that'll help you figure out what those withdrawal rates are based on your PSI and tip. So we'll get to that in a minute. All right, so we're gonna start with brazing. All right, so this is some of the safety gear that you should be wearing when you're welding. Not all this is strictly necessary for brazing, but for the cutting, it is. So I was wearing shorts, so now I'm wearing the chaps that are covering my legs, that are obviously not synthetic, closed shoes, jacket. This is a welding cap that will protect the top of my head and back of my neck in case there's spatter. This is not necessary for brazing. We'll have a list on the page of the things that's necessary for each kind. Sometimes people will put this to one side or the other, but it never goes to the front because that wouldn't do anything for you. This is to protect the back of your neck or an ear. So if you're brazing or welding to one side and you really didn't want little splattery bits of weld going in an ear, then you cover it with that. These are the goggles that I mentioned before. And these are just for brazing, so these just cover your eyes and are about probably a shade 5 to protect you just from the light from brazing. And then this is the full shield, so we're gonna set this to number 5 on the side for the shade. For the sensitivity, we're gonna put it at high sensitivity because we're inside. If you're outside where there's a bright sun shining, then you have lower sensitivity so the sun didn't turn the shade on. And then the delay, we'll put it like a medium delay. That means that after you're done, it'll stay shaded for a minute before coming back on, before letting you see again, because it'll still be bright. So just in case this wasn't clear, this is getting, this detects when there's really bright light and turns the shade on, so you don't need to lift it up and down all the time to figure out when you can see. And what's especially cool, I think, is that it takes the light from the welding and has a little solar cell to charge its own battery from the light from the welding. So this just goes in your head and then tightens and loosens like that. So we'll put this on, loosening it first to get it on and then tight. All right, so now we're gonna set up the workpiece for brazing. Oh, and the last important thing is gloves. So the gloves live right here. So we wanna put these two pieces together. And again, we're starting with brazing. So for most, I wanna say every, but for most kinds of welding, you need some kind of flux to protect the weld. So you need some way of protecting the molten metal from getting oxygen into it, which would ruin the metal. So in this case, we use painted on flux. So that lives right up here. There are different kinds of flux for different kinds of materials that you're brazing with. So in this case, this is for, well, it's just generic. Oh, so it says for brazing stainless steel, nickel, copper, brass, bronze, some others. But for example, if you're using silver, you need to use a special silver braze. And we'll grab the brush. And first I'm gonna grab this brush, which is labeled steel because we're on steel right now, just to clean this off. And I'm gonna grab some simple green, and I might remove the gloves for this, to clean it, to make sure there's no oil on it. Okie dokie. So now I'm going to grab a clamp to clamp these together. So the pieces are clamped together, and I'm just going to take this flux, because it's separated a little bit, and mix it back up. So it's nice and tasty looking. And then we're going to just put it on here. And so this is going to help protect the braze from the oxygen in the air. And then when we're done, I mean, we won't do this here because we don't actually care about this piece, but if you did, you could use hot water to get this flux off when you're done. Put that over there. And if this were to be dried out because someone left it without the lid on, you can just add a little water to reconstitute it. We should refer to the chart to see which tip we should use. So this is for the welding brazing tips. 2 tips here. You're welcome to get others if you would like. They are labeled SW203 and SW207. So we'll see which is more appropriate for this purpose. So SW203 is for 5/64, it says, which is about 2 millimeters. The pressure of both gases, it says, should be 10 psi. So we've selected the SW203 tip and we're going to put it on our handle. So this handle accepts all of the tips for brazing, cutting, welding, etc. So this slides right on here, and these O-rings, I mean, we just want to be sort of respectful of the whole piece so we don't hurt any of it because we don't want it leaking. That would be not good. So we're going to tighten down on this. And some other things that we're going to look at on here are these guys. These are called flashback arresters. So if, let's say, you didn't give it enough oxygen of the green one, what could happen is that acetylene flame is going to be looking for oxygen, and it's going to find it backwards. So it's going to keep searching for that oxygen down the tube, and it's going to shoot down the lines and potentially explode the tanks. So to prevent that from happening, we have flashback, which is what that's called, arresters to stop that. It normally makes a hissing sound if you hear that. So as soon as you hear any hissing and see your flame like pop and disappear and start hissing, you just turn these off really fast and turn those off, and hopefully you'll be good. But you don't want that. And so the way you prevent that is by making sure you have a healthy looking flame. As we'll get to later, good balance of oxygen and acetylene. So this is snug, doesn't need to be like wrenched on or anything. And then we're going to set the pressures over here. So we're going to set each gauge to 10 psi. So right now, so when you tighten, that increases the pressure, and when you loosen, that decreases the pressure. So we're just going to open the oxygen a little to drain what's in there. And then I'm going to, right now it's set to like 15, so I'm just going to let out a little bit. No. And now I'm going to bring it up, and now we're at about 10. And then on the acetylene side, which is on the left, we're going to get it to 10. So we're just going to tighten it a little bit until it creeps up to 10. All right. So then this tip is brand new, so we know it's clean. But if it was looking gummy or dirty, these are tip cleaners, so you can just open them up and get the right tip size and just scrape in and out a little bit to make sure to get out any gunk. And then we're going to need this striker to ignite the flame. So what we're going to do before we do that is get the fume hood set up. And I'm going to try to do all the talking before we turn this on because it's loud. So what I'm going to do is I'm first going to turn on the acetylene just a little bit until you can hear it. I'm going to spark this sparker by squeezing it in front of the flame, or in front of the nozzle. And then it's going to pop into a red flame, which is just the acetylene burning. And I'm going to do that under here because it's going to make a lot of soot, a lot of extra carbon that isn't being combusted because there's no oxygen. We want to suck that up. And then I'm going to slowly add the oxygen. And first, we'll be able to see the transitions of the flame. And there are 3 kinds of flame when you're using an oxyacetylene torch. There's carburizing, where there's too much carbon because it's just the acetylene, or there's too much acetylene. And then there's neutral, which you'll be able to see when the 3 flames combine into 2 flames. So there'll be an inner cone and then a bigger flame around it, sort of like white and then blue. And then if you add too much oxygen, it'll turn into a hissing sound, which is called an oxidizing flame. In general, we're just going to use a neutral flame. There are some times when you want one or the other, but in general, you're aiming for that neutral flame. So we're going to carefully light it up, and you'll be able to see that process. So I'm first going to turn on the acetylene, and I'm going to crack it open really slowly as I'm striking the striker, and then eventually it'll turn on. And then I want to keep adding enough acetylene till there's a flame that has tails flicking out of the end. So you'll see it's like a pretty red flame that's sort of like looks like a blazing torch at the end. Not blasting out, but enough so that it has tails coming out. And then that's when I start adding oxygen until the cones combine, which you should hopefully be able to see. And then when you turn it off, you turn off the fuel first, the acetylene, and then the oxygen. So it goes on and off in the same order. First acetylene, then oxygen, and then when you're turning off, acetylene, then oxygen. So I'm going to put the hood down, and then we'll see what that looks like. This is what too much looks like. A really sharp cone at the end that's really pointed and it's hissing. And this is what too little oxygen looks like, where the cones are separated. And that's just the neutral flame that we're looking for. Then to turn it off, first fuel, and then oxygen. So now we're going to look at the actual brazing process. So in this case, we're going to use these brass rods. So these are 16th inch general purpose. So they just unscrew, and they're really long, obviously. And we're just going to grab. These are pretty inexpensive. If you wanted to use more expensive ones, you're welcome to buy them. So we'll just leave these over here. And I've made sure to move all of the flammable things away so we don't accidentally light anything on fire. And then you're just going to be holding, depending on how your hands work. In your dominant hand, you're probably going to be holding the torch. And then in your non-dominant hand, you'll be feeding the filler rod. So you just have to practice feeding with your fingers to feed the rod. And you can also flip it. If you're more comfortable doing it the other way, you're welcome to do it that way. So we've put the flux on here. And then we're going to be heating this up. The bottom plate is the thicker piece of metal. So we're going to heat that more, because it'll require more flame to get to the same temperature as this thinner piece. And then when they're both pretty toasty hot, I'll take this and dab it in, and this should melt and braise the two together. And then we can go around a little bit and put them together just so you get a sense of how that works. So I just made a little bridge here between the two pieces of metal. Because of the orientation, and because this is a thicker piece, the metal wanted to go onto this parent metal, because gravity was pulling it down, and because it's thinner, so it was hotter. So I had to put a lot of heat into this one to get the metal to follow the heat. Wetting is the word for when this filler metal bonds to the two parent metals. So it takes a little while for it to wet. So that's brazing. And what you could do is you could use steel. That would be welding if you put these together with the same metal. It would just be a little harder because you'd have to get it really hot. So oftentimes just brazing is strong enough for what we want to do. So over here we have some of the safety gear. So these are more head covers, face shields, these are the dimming ones, jackets, and then up here we have an eye protection guide. So it shows what shade you should use for whatever process you're doing. Process is just a different word for the types of welding things that happen. It's like plasma isn't technically welding. So for Oxy Acetylene welding, which we just did, it says 5 to 8. For Oxy Acetylene cutting, it also says 5 to 8. So that should be okay, even though there is like more flame and stuff going on. These others depend on the amps that you're doing it at. So just make sure to refer to that when you're doing the other processes. So we're gonna go over here, and I just forgot to mention that when you're using the torch, the outer cone is much cooler than the inner cone. So if you're doing something a little more delicate with softer metals, or you just want to warm it up, you can use the outer cone. And then when you want to really punch a lot of heat in there, you can use the inner really hot cone. So we're going to switch over to cutting. So we're going to take off this brazing tip and put it right here, and then pull out the cutting tools. So this is the cutting head, and this goes right on here, and it just drops in and then screws on. Again, not crazy tight. And cutting is a little different. So the way it works is we have the same oxygen and acetylene coming in. It's actually, when you're using the cutting torch, first it's just getting it hot, and then it's getting it really hot, almost to melting, and then we add a lot of extra oxygen. What it's doing is that oxygen is reacting with the steel. So this only works with ferrous materials. You can't cut aluminum this way, and it just vaporizes that metal. So there will be some splatter, but the goal is for you to be cutting, and that extra oxygen, when you're squeezing this lever, is just vaporizing that steel. So that's pretty cool. That's how this works. And so we're going to set it up. We're going to check the chart on the wall. So we have 2 tips here. Again, you're welcome to get others if you want. So we have the SC12-1 and SC12-0. So if we go and look at this chart, the SC12-0 is appropriate for 1/4 inch, which is about what we're doing. So we'll use the 0. It says that we want, on the regulator, about 30 psi of oxygen. So we want more pressure of oxygen. And then on the acetylene, 10, the same 10. And that is going to consume on the fuel 7 cubic feet per hour. So that's under our limit of 10, so that's appropriate. So that's how you use this sheet to figure out what you can use. And then some other interesting things on here. For 0, it says our speed should be 22 inches per minute, which is obviously pretty hard to figure out when you're going by hand, but just have a relative sense. Yeah, so that's cool. So we'll go back over here. And this is size 1, which we don't want. That's for thicker metal. So we'll put that there. This tip just screws on here. So you put the tip in like that, and then this cap screws on and tightens just like that. And so we're gonna, same here, make sure that's tight. And we're gonna start by having that guy closed. And what we're gonna do is light this up. You wanna hold it maybe 1/8, 1/4 inch away, and you're gonna start at the edge. You can go back and forth with the preheat flame to get it preheated. And then you're gonna start at the edge and squeeze the handle and then move, and you want the material coming out the bottom to be at a slight backwards angle. So if it's shooting straight down, you're going a little too slowly. And if it's shooting way back, you're going a little too fast. But if it's going at a slight angle, that's the speed you want to go at. Nice and easy. And obviously, if you were doing this for a bigger thing, you could have a rig to have it holding it at a proper height for you. Something else is, please don't cut the table. So make sure to have it over, not the table. That would be good. And yeah, and again, if there's something heavy, make sure your feet are out of the way so it doesn't fall on your feet when it falls. So just to clarify before we start, so on the left side, this is the acetylene, which we covered before. So we want to crack that open just a little bit and then spark it so that we light that first red flame. Then we want the oxygen, opened up most of the way. That we can just leave pretty wide open. And then we want to start with this closed. So this controls how much oxygen is going to come out during the preheat. And then, so we're going to light this, and then we'll open this slowly. This oxygen's already open, and then we'll modulate with this until we get that good neutral flame for preheating. And then we blast with the oxygen handle that lets all of it come through and skips this valve. Keep closed, open, and let's get started. And I'm just going to get the flames so that they come just down like that. So we just have those little baby flames at the bottom. And we're going to come over here and heat the material up. I'm using both my hands, one to keep the distance and the other to move it back and forth. I'm getting nice and red hot. And so in this next pass, we should be red and red. Okay, so we're red hot now. And it's stuck here. And then acetylene first, and then oxygen. So as we're looking at this, we can look at the bottom and and see that there's not too much material. It's pretty flat, which is nice. And it's a pretty straight cut. There isn't a heavy bevel, so that's pretty good. And yeah, so that's cutting with the Oxy Acetylene. So we've covered most of the topics at this point. Something I want to reiterate is that within this length of hose is about a stick of dynamite worth of energy. So you just want to be really conscious about how you treat this, making sure you aren't getting fired near the hoses. And when we're done, we're going to drain the hoses. So this step is pretty important. We're going to move this guy out of the way. And over here, we're first going to turn the tanks off. So our acetylene should just be about a half turn to turn off. Oxygen, we're going to turn a whole bunch. And that's off. And now we can turn the hoses, drain the hoses. So the oxygen's already on. We're just going to open that and bleed that. It's called bleeding the hoses. Close. Now we can close the oxygen so the next person doesn't get surprised. And we're going to bleed the acetylene, and you can watch. So now we can see the pressure is 0 on both gauges. These are snug. It's super important. You really don't want to be the person that drains hundreds of dollars of gas by accidentally leaving it open. So make sure to close the tanks when you're done. We can leave the tip on there. If you want to be really considerate to the next person, you could use the tip cleaners and clean out the little holes so that it gets a nice clean flow the next time. We're going to pop you off. Put you there. And some people like to bring the regulators back to 0. Here it's okay if you leave them back at the pressures they were set at, because that's likely what the next people will want. This is a bit of a mess, so we're just going to coil this up so it doesn't get hit. And there is some splatter that's made in this process, so if there is any mess, you just want to be sure to clean it up when you're done. And we're going to close this up. And then put our tools away. Thanks for watching.